At Valve, I spend most of my time thinking about the interactions of psychology and gameplay. You can think about how to foster cooperation, competition among players, how to manipulate visual attention, designing experiments for in-game economies, all sorts of kind of, wherever knowledge of human behavior could be useful, that's maybe where I can jump in and be helpful. And so one thing I do a bunch of at Valve is a bunch of data analysis, working on playtesting, working on gathering data, aggregating data, analyzing data, and so forth. And so we spend an awful lot of time thinking about how to make the best of it. And so I'll kind of ramble at you guys for about an hour today. I'm much more interested in what you guys have to say, so my talk is long. I'm going to try and go through it quickly, but definitely at the end, my email address will be on the screen. And if you have questions, either hit me up now after the talk, or I'll go outside in the coffee area and happy to chat with anything or with anybody about anything. So let's get started. Breaking apart the first, I only have 2 slides that actually have like sentences you have to read on them. For the first part of the talk, making the best of imperfect data. What I mean by that is turning the information we gather into a less biased, more complete, and wider-ranging set of meaningful conclusions. I just want to be smarter about the data we're collecting and making sure that it's reflective of what we want it to reflect, and that it's telling us a story that we can use to make smarter decisions down the road. In the second half, reflections on an ideal world. This is my high-minded kind of ethos for the talk, and this was more useful actually for me. I don't want to really inflict it on you, but I'll read it anyway just so you can get a sense of where my mind was when kind of thinking about the talk. So if we think about where our problems lie, we don't ignore them, and we improve our understanding. If we think about what could be possible, then we're innovating and expanding the scope of our profession. And if we understand how to link between these 2 approaches, between identifying problems and thinking about the future, then we're making progress. So I want to fix the issues we have to the extent that we can, and I want to think about what we're not currently doing that we could be doing. That'll make us all better researchers and better academics, better people who can make better games, better game developers. So this is my joke slide. The guy on the couch is our CEO, Gabe. This is me pretending to be a clinical psychologist, and I have my diagnosis. I'm not a clinical psychologist. I am experimental. You guys likely understand the distinction, but just kind of making the point that what I do again at Valve is just taking advantage of what we know about human behavior and applying it to problems that we face, typically in game design. So a quick overview of the talk. I'll go through the current state of affairs, kind of just run through where we are. I'm not, by no means, am I claiming to be exhaustive. I'm just going to say, hey, okay, here's, a summary of what we do now and some issues we face and what's going on. And then I'll talk about what we could do next, the path between the current and what will eventually lead to the future, like where we could be. What would be a more idealized or realistic or even perfect state of affairs. So for the current state of affairs, to break apart this section, talk about ways we get data now, talk about some issues and problems we currently face, and go into at least, again, what I think is some information we're currently lacking that would be pretty useful. Again, not meant to be exhaustive. You guys will have better ideas than I will about problems we have and information we're lacking, and I'd love to hear about it afterwards. Or you can just yell it out when I'm talking. Either way is fine. So again, a lot of this is familiar to folks, but again, just want to get some common grounding for everybody. So data collection, we all, or most of us, I assume, are doing experimentation or play tests of some kind. Direct observation, just sitting behind somebody or sitting in a room watching them play your game. Think aloud, letting people kind of, give insight into, I guess, their introspective processes as they go along. Doing usability tests, task analysis, and so forth, and obviously, directed Q&As at the end where we kind of poke at people and try and figure out motivation. I have another bullet point, metrics, where I'm, descriptive statistics, and obviously things that get much more complicated. But what I really mean by metrics are quantifying behavior. So having some way of saying, hey, here's something that people do, and here's a way of interpreting it, telling us how likely it is it's going to happen, and here's a summary of it. And really, metrics kind of apply to the data you get from playtests as well, right? If I have 1 person out of 10 tells me a map is challenging, that's not really data. If 3 out of 10 tell me it's challenging, okay, maybe there's something there. If 17 out of 18 people tell me it's challenging, okay, well then I can have fairly high confidence that there's something going on. And so, the distinction between kind of quantitative and perhaps more qualitative kinds of, playtests is kind of a misnomer, I think. Really what we're after is some way of quantifying behavior, and just the methodology we use to quantify that behavior tends to vary. That no longer works. Okay, so this is just graph some data. This is performance data from Counter-Strike, I think. What's actually on there is not important, but just kind of making the point that we're always kind of, at least at Valve anyway, we're gathering a bunch of data, and trying to make sense of it can be a puzzle sometimes and can be tricky. And so this is just one example of the kinds of things we do. And as we go through the talk, I'll kind of lay out a few more examples, and we'll see if anything resonates. This is another example of basic data we can do. This is a heat map. These look cool. This is just a map in Team Fortress, one of our games, and this is a heat map of where deaths occur. The reason I have this up here is because this is not as useful as you might think it is. It looks cool. People see it and they're like, oh yeah, you can figure out where choke points are, figure out where the map is imbalanced, and that's true. But it ends up not being that usable. Like we don't actually find that many surprising results from the heat maps. Like we typically when doing kind of I guess level design, we can come up with where we think in those common places, people we're going to run into problems where we think, and obviously we find surprises. By no means we're not perfect, but not even close to it. But the notion of like a spatial visualization of where people are dying in theory seems pretty useful, but in reality is actually not. And so like trying to understand why that is and how we could take that and actually make it more useful and what other kinds of information we should be kind of using for heat maps, is a question we're currently wrestling with. So I have this up here saying, hey, here's a tool we use that is not as useful as it could be, and it's something which is at least to me kind of a signifier of like, okay, there's something going on here. Let's take some time and think about how we could actually make better use of it and make this a more useful tool. So I'm calling these alternative methodologies just to kind of draw a distinction between them and maybe the more traditional playtest methodologies, but really it's all just finding the appropriate tool for the job. And also it was really easy to kind of organize this around the notion of different kinds of measurement. But surveys measure opinion, eye tracking can measure attention, physiological signals can measure emotion, and experiments can measure effect. And by experiments I mean like actually scientific controlled experiments, and I'm going to spend a lot of time talking about that as we go through the talk. So this is a bunch of eye tracking data. Again, another heat map, but kind of showing just essentially an index of attention, right? It's letting you know where people are attending, and you're just looking, and eye movements follow attention. So where they're attending in the display at a point in time. This is interesting data. I mean, you can use it to parse interfaces. You can detect expert novice differences and so forth. One thing you might notice if you're familiar with Dota, this is Dota, one of our games. Essentially a modified version of an RTS. 2 teams of 5 heroes are attacking each other and trying to destroy the other team's base. If you look down at the mini map in the bottom corner here, I noticed this after I made the slide. This guy, he's looking at his side of the map, always. Not once does he look at the enemy side of the map. Probably not a good Dota player. So data we can use to infer kind of, we use this sort of thing actually to, look at how experts scan the display, how novices scan the display, and then you can think about, okay, like, well, how can we, kind of shallow up a learning curve by like turning the expert, or I guess the novice scan patterns more into expert scan patterns. So again, another piece of data that's interesting and, a tool that people are using these days. This is our, I guess this is maybe 3 years old now or 4 years old now, but this is our really, really high-tech biofeedback sensor. For $5, we built a device that measures skin conductance, like galvanic skin response, right? It's not expensive. You just need, 2 metal contacts, an ace bandage, Velcro strap. You can use the ace bandage to hold the contacts up against your arm, pass conduction current through it, measure the change in resistance, and you're measuring physiological arousal. So in essence, we're not getting valence from it, but if we're smart, we can infer valence, and then off we go. And so for $5, you can get some insight into the I'll say emotional state, but I'm going to be hand wavy about it, of a player while they're playing their game, or while they're playing your game. Current state of data analysis, everyone's favorite, statistical test, t-test, correlations, regressions, ANOVAs, and so forth. I'm not going to get into the frequentist and Bayesian distinction, but if we want to know the long-run relative frequency of things, we'll go frequentist. If we want to know kind of our best estimation of the current state of affairs, we'll go Bayesian. What I'm more curious about is doing the more exploratory and automated analyses, like data mining and machine learning are buzzwords that people like to use, and that's fine. Here, I'm just delineating them by saying, okay, exploratory analysis is going to be data mining, when we're looking through our data trying to find answers to particular problems. And I realize that's kind of a broad generalization, but I don't know of a better description for it, or a better definition for it. Machine learning is more of an automated approach, where you say, hey, okay, here's a bunch of this data, go run a bunch of market basket analyses, or k-means clustering, or decision trees, or neural networks, whatever, and give me some results, make some prediction for me, tell me something new that I didn't already know. And so these are processes that people are starting to use, but my assertion is that they're underutilized, and we could be doing a lot more with them than we currently are. So apologies for the scale on some of the graphs. Really, it's the actual data is not too important, but just to kind of lay this out for you, this is a graph of weapon purchases in Counter-Strike, one of our games. The x-axis is the amount of money you have after each particular round, so increasing from left to right. And then just what weapons people are buying in each round. And so you can see kind of that, in the beginning, they kind of focus around a few set of weapons, and then eventually it kind of stabilizes to one of 3 weapons, essentially, with, a little noise at the top and the bottom. This is fine. This is an interesting graph. It shows me something. I have it up here because we've done analyses on this graph. We've said, okay, the game is balanced because a third of the people are taking the AWP, or a little less than a third are taking the M4A4, and a third are taking the M4A1. That's fine. I want to know how to do more with this data. I want to know what analysis to run on this data. I have my own, we can run categorical regressions, and we can, try and predict, at what point do people shift from a certain class of weapons to other class of weapons, and that's fine. I want to know how to do more with this data. I know there's more information that I can extract from this graph, and I don't really know how to do it. I'd like to learn, though. I'd like either, I'd like a tool that would help me do that. I'd like someone to help me do that. I'd like to have the ability myself to help, to do that, because I think there's a lot of useful information here that we are not currently using. We can get the rudiments down for weapon balance and say, hey, yeah, if there was only 2 weapon choices before and now there's 3, okay, that's a change. We can measure that. That's fine. This is actually what happened. We made a change and added another weapon and got this graph. The M4A4 was gone and used to be half and half. And so that's fine. So we measured a change and it worked. But I know there's more information here. And so, again, I look at this data and I'm like, okay, what am I missing? I'm not sure what I'm missing, but I feel like there's something there, and I'd love to know what it is. And so the whole point of this talk is really just to, I don't know, as best I can, encourage people to ask questions. I mean, that's all I'm after. That's what I'm doing, is I look at this and I wonder what's going on. And so, this is me trying to, and probably not needing to, but convince you, hey, there are lots of interesting questions out there that we're just not answering, and it'd be great if we could, had better tools, whatever they were, to make us better researchers, to go and answer these kinds of questions. So this is just, kind of a snapshot of, some Tableau dashboards that we use for Counter-Strike, hitting back on the data mining kind of point, where it's we have all kinds of questions that we're exploring, like popularity of maps, balancing maps, weapon performance, operationalizing skill. I'd love to know how to operationalize skill. If any of you guys have ideas on how to actually measure skill in a video game, we have our notions, and lots of people have different definitions, but I don't know, well, I mean, I'll just say it, okay, I don't know of anybody who's actually come up with a canonical definition of skill that, well, whether it's generalizable or not, but says, hey, yeah, this is how you measure it, and this is what you do. We can measure certain outcome variables, and we can look at performance, and that's fine, but performance and skill are not the same thing, and how you actually break down the components of skill and turn that into something turn it into something that can be manipulated, so we can actually train people to get better at a game, and perhaps transfer to other tasks. That's a trickier problem. So it's something that we're constantly thinking about. But again, the point of this is just to let you know that at least as a company, we're constantly analyzing the data we have, we're tracking everything and trying to figure things out, and lots of things we know and a lot more we don't know. I just have this last graph up, which is just kind of a few examples of various machine learning techniques. You have a data set on the left, and you're trying to categorize it and classify it in various ways. And second column is a support vector machine, and third column is random forest. That works now. And fourth column is a decision tree. I know a little bit about how to do these. I'd love to know more. I'd love to be able to know when to apply a random forest or a decision tree or a support vector or a neural network or a discriminant function analysis or k-means clustering, and say, hey, okay, this kind of data set is suited for this, and these are the kinds of biases that I'm going to introduce by doing this analysis, and these are the kinds of questions I can answer. I have some of that technique, but there's a lot more I don't know, and if I had that ability to know what to do, then I'd be smarter, I'd be a better researcher, and I'd be able to draw more meaningful conclusions and then share my data with everyone else at conferences, and they would like me, and that would be great. There's a personal motivation, but obviously, it's obviously professional, right? I mean, I want to be better at my job. I want to be able to get more out of the data that I have, and so if I was better at this kind of stuff, then likely I would be. And we're back to failing. Okay. Okay, so I went over data collection and whatnot. The word I'm going to use now. Well, I guess we'll get into kind of current, at least some current issues with kind of our current processes and techniques. Definitely feel free to pick at me and disagree or agree wholeheartedly if you think I'm saying something smart. But I'll walk through some biases in data, you know, questions about lack of resources, and some kind of experimentation shortfalls that we kind of, at least in industry, undergo. I'm going to say the word biases a lot, just because I think that is likely our biggest problem. Is, you know, there's biases we're aware of and we can't account for. There's biases we're aware of and we can't account for, and there's definitely biases we're not aware of. And making sure that you know, we're given the most accurate interpretation of our findings as we can is tricky and tough and requires a bunch of honesty, and is sometimes a struggle to kind of account for all the possible confounds and biases that are present in the data. And so always being cognizant of the ways in which our data can be manipulated by external factors and is being manipulated by external factors is important. So I'm going to say it a lot, and apologies in advance if you guys are not a fan of hearing about biases in data. So the questions that I currently ask, at least when I'm looking at data, is obviously, you know, what biases are present, like what, you know, at least things I'm familiar with, things I've had exposure to, things that you know, might be present, and what can I do about them? You know, can I get rid of them? Can I account for them? Can I parcel them out? Can I make sense of them? You know, every time I'm doing an analysis, these are the questions that are running through my head. Is like, how do I account for what's going on in the data, right? And you know, again, it's not always the, you know, the most fun part of the process, right? You have a cool finding, like, great, you know, oh yeah, playtime went up, that's fantastic. Okay, well, did it go up just because, you know, maybe like League of Legends servers were down for, like, you know, a day, and like, okay, everyone's playing Dota now. Like, I mean, like, what, you know, and we had an update, but it was, you know, there was actually something else going on. So, you know, it's a question that, you know, we get excited about our results, but, you know, this kind of, asking these questions kind of tempers what's going on, and it's important because we want to make sure that we're actually measuring the truth and what's, you know, measuring the reality of our situation, and not being convinced by, you know, data that might be tainted or contaminated in some way. So just, you know, one common bias, there's a whole, you know, there's hundreds of cognitive biases. I mean, this is just a cartoon that shows anchoring, right? Depending on how you frame a question, right, you can change the way people will respond, right? You know, seemingly innocuous things will impact the results that you get in a variety of ways, right? Like, we all know the confirmation bias, right? If I tell you something that accords with your expectations, you're more likely to account for it. If I tell you something that disaccords with them, you're more likely to disagree with it. If I ask you to estimate the price of a car and I use $100,000, your estimate's going to be higher than if I ask you to estimate the price of a car and your estimate is $20,000, right? We like to think that we're completely perfect, rational people. We are far from it. Our explicit beliefs about what we do and say, like, oh, I seek out challenges. You can say that, you can believe that it's true, and you can be completely wrong. We can, you know, all the time, you know, our explicit beliefs, you know, are in kind of, I guess, conflict or disagreement with our implicit beliefs, what we think, and we don't actually. It's tough for us to acknowledge. And then again, I won't pick on you guys. I'll pick on me. I mean, like, you know, I find myself often being like, oh, I thought I was this one way, and then you kind of observe your behavior as critically as you can, and you understand, yeah, actually, well, my behavior is not kind of in accord with that particular belief. I need to modify it, and you know, I'm not who I thought I was. So I don't know. I mean, the whole point of this slide is just that the data we get is, you know, delivered by people, and people are kind of affected in a variety of ways that are sometimes, you know, visible to them. You know, they are consciously aware of it, and oftentimes they're not. And so it can be innocuous things like the phrasing of a question, or it can just be kind of the way our brains are kind of, you know, I guess the way our brains, I guess, process the world, right? There's far too much information for us to deal with everything that's coming in all at once, and so we make assumptions. Our brains are matching patterns, and we will see signal and noise and signal, and it can be tricky sometimes to parcel out exactly what's going on. So I'll get to some of my, at least, well, no, I won't say favorite biases, because I don't have any favorite biases, because they're all stupid, but just, you know, things that happen, right? We bring people in to playtest Valve games, like into Valve. They know they're at Valve, so they know the company. That's a bias. They know the game. They're playing Left 4 Dead 2. Well, if they know Left 4 Dead 1, that's a bias. They know the genre. This is a first-person game. There are certain conventions or expectations they have. That's a bias. They play in groups. We don't, well, when we have multiplayer games, you know, we'll do Q&As individually at the start, and then before we bring them into the group, because you guys are likely all familiar with this, in a group, the first person to speak wins, right? People get anchored to that person's response. How challenging was the game? Okay, if I say it was challenging, then, okay, people are anchored to that, they respond differently. If I say it wasn't challenging, then you're not going to speak up and say it was challenging. You're going to be like, oh yeah, it wasn't. Or you're much less likely to do so. So we at least to account for that one, at least we can have people play individually, and then kind of bring in the group discussion afterwards when we've gotten the individual data that's hopefully been less biased. Also, the playtester's not unbiased. I was being silly and came up with a rhyme, want to impress. They want to impress us, they want to profess to us, but really they have their own motivations for why they say what they do. Sometimes they want to impress us, sometimes they want a job, sometimes they love the company and can't be critical, sometimes they want to be overly critical. They're not, they're human, so they have, their goal is not the same as ours. Ours is to get, unbiased critical data about our game. Their goal is maybe to do that, but maybe also to be happy they just get to play a new game that's been unreleased, and that, affects the data they give us. Also, we're not unbiased, right? And again, I won't pick on you guys, I'll just say me. Like, I would love to think I'm a completely straightforward, rational person who, I guess always able to think critically about any particular situation, but of course I'm not. I'm going to fail all the time at that, and so I'm going to place my expectations on the data I gather, and that's going to impact the quality of my results. And so I'm going to try as hard as I can not to be biased, but I'm definitely going to be biased, and that's something I need to account for if I'm honest with myself. So along with I guess biases that come from playtests, right? It's just thinking about biases that are inherent to a particular data source, right? I mean, everyone's been on the internet. You've likely all read forums from time to time, perhaps, maybe not. If you haven't, what happens on forums sometimes is you get an echo chamber where a viewpoint will be espoused and people will either agree or disagree, and the volume can get loud. And you have a problem, well, the issue is trying to figure out, okay, is that data actually representative of what's going on? If there are 1,000 people on Reddit who are complaining about a change we made in Dota, is that a valid complaint? We have 10 million people playing Dota every month. So 1,000 out of 10 million is it's a fraction of a percent. Is that just 1,000 people getting in an echo chamber and saying, hey, this is a problem, or are they actually representative of the population at large? That's actually a tricky problem we have yet to solve. One thing I'd love to do is actually kind of manipulate this and have some sort of survey in a forum where we either quantify people's sentiments in some fashion, or like have a survey in a forum that where people respond to, then actually measure that change somehow in game. So we're like, are you going to play this? A survey like, are you going to play this game mode in Dota? And 72% of them say, hell no, we'll never play that game mode. But then you run the test and you see that the population at large, like 97% of people play the game mode. Okay, you can start trying to attack the problem of how reliable is the data we get from these forums. And emails are the same thing. We get a bunch of emails, and most of the emails are angry and negative, telling us why but they use stronger words sometimes. Sometimes they want you to die in painful ways, which is a slight overreaction, I guess. But I'm glad they're so passionate about the choices we made in the game. But again, trying to parcel out data from somebody who sending you an email. Well, people are more likely to send you emails or post in forums when it's something they're upset about, as opposed to when, oh yeah, this is really good. And so trying to figure out again, extracting signal from noise there is tough. If we do in-game surveys, and we do have in-game surveys, right, they're going to be affected by lots of things. The data you give us after a win is going to be different from the data you give us after a loss, for example, right? That's just a problem we have to account for. I mean, you can account for it, as long as you can identify it, but there are lots of factors that could be going on that will affect the quality of the data we get. By contaminated samples, I mean a few different things, but again, not to pick on Reddit, but just as an example, if a bunch of people on Reddit decide to do a particular behavior in game, hey, let's all start griefing, new players in Dota, right? We might not see that, and all of a sudden, a bunch of new players are sending us reports of hey, everyone's being abusive. And is that indicative of the game at large, or is that because there's some external factor that's contributing it that's maybe localized in time? Who knows? We also have expectations, right? We have expectations as game developers, and the players have expectations. And so, if they expect a particular kind of game, if we make a game that people think is akin to a Call of Duty game, right? They have expectations they bring from Call of Duty, apply it to our game, and that's going to affect the data they bring to us, right? We're not operating in a vacuum, which I guess is the point of this last slide, is that people have kind of these preconceived notions that we'll bring to bear, and that will contaminate the data that you get. It's never clean. We want it to be clean, but there are always other factors going on, and so we're going to do the best job we can to account for the factors that could be shading our data, but it's going to be really tricky for us to eliminate all of them, and also to be aware of all of them. And so, again, these are just issues that we have all the time, and we try and be as smart as we can, and likely we fall short a lot of the time. just going through again, so a few more biases. I told you I was going to save us a lot just because it's something I think about quite a bit. But we have data could be incomplete or missing. Obviously, there could be all kinds of confounds that come into the data, seasonal effects. A bunch of people who bought the game on sale, right? Might be a different kind of population than the people who bought the game at full price, a potential confound in any analysis of results that you have. Oh, purchase rates went down. Well, they went down because you brought in a bunch of people who wouldn't have bought the game normally. Purchases of in-game items went down. So, I mean, that's one example, and everyone can probably think of thousands of ways in which that our data can be confounded. Data can be incorrect. Okay, so say our measurement of fun is how long people play the game, which I think is a fantastic measurement of fun. And I'm going to say it again in the talk later, because I think it's awesome. What if that's wrong? What if instead of people playing the game longer, it's people playing more rounds of the game? So like, for example, in Dota, we made a change that affected the game length. Like game length went up by 5 minutes. And so we made the change, and people started playing longer, and that's good, we think. But what if we're wrong? Like we just think, I mean, it just makes sense to us that people playing, at least having longer games and hopefully playing, well, would be a good thing. But what if it's actually like just them playing more games? And so we should have made the game shorter so they could play more games, and that leads to longer player retention down the line. So our data could actually be wrong. Like, we need to make sure we're actually measuring what we think we're measuring, and so that becomes tricky when you take that final kind of like it's the notion of saying, hey, we have a hypothesis about what is going on, to this is how we measure it, is a whole bunch of links in a chain. And if any of those links is kind of faulty, or you're making an assumption that doesn't actually carry all the way through, then you run into problems. And so making sure that your data is actually corresponding to what you think it is, that's really tricky sometimes. So we run into that problem quite a bit. I guess the mic didn't like that. And again, the final point I want to make is, just in terms of like a more technical detail, right? Our data can violate statistical assumptions. If we're running analyses, and again, what I'm showing here doesn't matter, but it's just showing 2 curves, right? Or I guess 4 curves. But the point being is, like, if I have data that's essentially normal, that's fantastic. But I'm running tests that assume normality on data that's not normal, well, then my data is faulty, right? As a fashion, or at least it's a problem I have to face. Again. Yeah, it's a technical detail, but this could have quite dramatic expectations if you say, oh yeah, like this is a meaningful this is not a meaningful difference, but it's meaningful here. Well, make sure that you understand. I mean, again, this is trivial to solve, right? You actually have to look at the shape of your curve and run tests for normality. But sometimes we're in a rush, or sometimes we're not thinking things through. And so just being aware that the shape of your data matters, and obviously all kinds of things that go on to when you're running statistical analyses is important. And so. Yeah, it's just one more issue on top of everything we've been talking about already, where it's like, hey, another place where things can go awry, which is unfortunate. So resource constraints, everybody is familiar with these. I have it up here just so we can think about, again, like this is how I think about like the current problems we face is not having enough time. That's definitely our biggest. Valve is doing very well. We have lots of money. We'd be willing to spend it, I guess, but money obviously is not infinite and can run into issues. But we'd love to have more time. And so one kind of underlying theme of this talk is thinking about ways in which we can create more time for ourselves, so we can become more efficient in the analyses we're running, and the tests we're running, and the experiments we're running, and how we gather the data, and how we analyze the data, how we interpret the data, and so forth. But trying to create more time, create more money, get more equipment, definitely get more expertise. I mean, I talked more about my desire to get better at machine learning, but I wish I was better at Q&As. I wish I was better at analyzing think aloud protocols. I wish I was better at designing experiments. I think I'm okay at some of that, but I want to get better so I can gather better data, become smarter, make better decisions, and make better games. Hardware and storage space, I mean, we have lots of data. You need to store it somewhere, and you need to be able to extract it efficiently. And we run into problems. At one point, I think for Counter-Strike, which is a shooter, a first-person shooter, 2 teams of 5, millions of players a day, we were recording every bullet fired, like every bullet fired. So thousands of bullets around times 10 players in a round times 30 rounds in a game times X games times millions of games a day, where you were standing, where the bullet landed, did it hit anybody? That's a lot of data. We stopped doing that because it was, I think we sample it now. And it's in theory, it was kind of nice, but it led to practical issues where we couldn't efficiently analyze it. And so, we kind of had to pick and choose what we wanted to do with it. The last point is also something I want to harp on, the capability to eliminate issues. there are lots of examples of this. I mean, again, not having any of the above could be one, I guess one indication of not having that capability. But say there are changes I want to make to a game. And I want to actually, and I'm going to get into experimentation soon, but I wanted to divide the game into 2 experimental groups and say, hey, let's test this manipulation on half the population and this on the other half. Sometimes, in fact, lots of times I can't do that. In academia, we can do that. That's fantastic. In industry, it's tougher. I may have tests I want to do to gather data that will say, hey, let me solve this interface problem. So I'm going to give half and half this different interface and see which one is better and have some measure of success, and off we go. Oftentimes, I can't do things like that. It's really tough to justify to players why their game experience is going to change, especially if they believe, rightly or wrongly, that their experience is going to be inferior to others, right? The perception of fairness is incredibly important, and so that's a constraint we have. And so what it does is it kind of precludes us, from eliminating certain issues that might exist sometimes. So we have to be smarter about it and take more effort, and spend more time, spend more money, and figure things out a different way. So, it's a constraint, right? So we have, you can identify a problem, but if you don't have the ability to fix a problem, that's really frustrating, and it's a constraint that we operate under. So, again, just one more thing to add to the list of problems that we'd love to solve in the future. Just kind of, branching off that last question, I'm going to go through this slide pretty quickly, but, again, going back to the theme of asking questions is trying to figure out which questions we focus on and why. I work on Dota a lot. Not sure if you guys are familiar with the internet. Sometimes people are not so nice on the internet. Sometimes they're mean to each other, and that is okay. But I'd love to solve that problem, right? I'd love to make people be nice to each other on the internet, especially in games, in competitive multiplayer games. I'd love to be like, hey, here's what we can do to make people play nicer. I think that question is incredibly important to focus on. I think it's really valuable. I think more people will play Dota, people will be happier, people will love Valve because we solved the internet. But I mean, is that the right one to focus on? Every day, I have to decide what do I focus on and why. So if those of you unfamiliar with Valve, Valve is a flat hierarchy. I don't have a boss. Every day I get to go in and ask myself that question. I get to decide what to work on. And so I need some way of effectively prioritizing what I do and where I allocate my resources. And should we spend $50,000 on an eye tracker? I know they're coming down in price, but sometimes they stay expensive. And how do we decide to do so? I have my own kind of internal tools and proxies for what's going on, and you gather data from folks, right? I have my experience and analysis I've been running, and we have data from our fans and data from other people at Valve, and data from academia, and the sun is shining that day, and I feel more optimistic, so I'm going to tackle the harder problem, whatever. But having a better understanding of better tools to create a process to figure out what's the most valuable thing I could be doing, that's tricky. Should I be working on player behavior in Dota? Should I be working on, increasing revenue, increasing, sales of in-game items, or figuring out a way to get people to invite their friends to play Dota, or how do I make the game easier to play? These are all really big questions, and there's smaller questions that I could spend a day on and maybe help solve, and then there's these larger questions, and just so that is as working in industry as a researcher, that's something I have to figure out. Is what questions do I focus on and why? Where do my resources go? And so, again, constantly thinking about I guess how best to allocate my time, my most valuable and scarcest resource, and that's tricky. And so tools that we can create to give us better ideas of what are the main problems are incredibly useful. And there's not much that's systematic about that, and maybe it can't be. I mean, I might be going pie in the sky here, and that's fine. But again, this is just something I think about because I'd love to have a better way, a better process for figuring out what to work on. So experimentation, again, I probably don't need to say any of this where everyone's familiar with it, but I do want to make this point because at least in the industry we have this problem where we don't have the ability to really run or often run truly valid experiments. Correlation, everyone gets the correlational causal difference, right? Correlational reveals relationships between data. Causal is where you actually say, hey, here's an experiment we ran. We had a control. We have an experimental condition. The only difference between them was this slight tweak, and we measured an effect, and that's fantastic. But oftentimes in academia, or sorry, in industry, I'm skipping the retrospective real quick. We don't always have a valid control, and we may not always have a valid test condition, and maybe our control is the state of the world 3 weeks ago, and our test condition is the change we made in the last update now, and we measure the succeeding 3 weeks, and that's fine, but that's not a clean experiment. And so like this is an issue we have all the time with making sure that, hey, okay, can we actually get a valid baseline? Can we actually get a valid experimental condition? And again, I have retrospective, prospective up there. Are we looking at data we've already collected, or are we being kind of predictive? And there are factors. If you're looking at retrospective, well, you need to account for all the possible factors that could have been going on at that point in time. And if you're being prospective, well, you need to be really smart about what other factors could be impacting what's going on. And so, again, we don't have the ability, or we usually do not have the ability to bring people into a lab and have them play two different versions of the game, measure the difference between the two groups, and say, hey, yeah, here's our clean finding. That's not how it works. We have constraints that we operate under, where we have a game that people are playing, and we can't do something that negatively impacts the game experience. And that will definitely preclude us from having a valid control sometimes, and from having a valid test condition, or being able to be prospective. Usually we can be retrospective, that's fine. And so yeah, we can look at a lot of correlations, and less kind of causal relationships, and that's frustrating. Because our data is not as useful or as clean as it could be. More problems with experimentations. We talked about confounds and things that could be going on. People from Reddit are having a bad day and they decide to mess with your game, or some change you make has conflicts with player expectations and they respond poorly. There's also conflation of effects, which is kind of like confounds, but really, when we release updates to games, for example, a whole bunch of things are changing. And so if we see, okay, yeah, we added 1 million new players this last weekend because of these changes we made. Well, there's a whole bunch of factors that lead into that 1 million player increase. Maybe half of them came from a change in the game balance, and a quarter of them came because we introduced new items in our in-game store, and a quarter of them just finally came around because we're reaching critical mass and network effects are happening. And so trying to parcel out like the impact of each of those effects is essentially impossible given the way we do things. We're just constantly updating and changing things. And so like saying, hey, okay, we have this one result, more players playing the game, but trying to parcel out like what factors are causing that can be really tricky, and that's tough. So it leads into the inability to isolate effects. We also do results-oriented experimentation. Like we have a goal of saying, hey, we want to change this metric, like get more people to buy, get more friends in the game, get people playing longer, whatever. And that's fine, but it'd be nice if we could do more theory-generated stuff too, right? Like get an understanding of why people are doing what they're doing and build up a knowledge base and then apply that going forward. And we do try and do that, but we have certain constraints, right? I mean, there are differences between academia and industry, and so one problem we have is, well, the experimentation is more results-oriented often than theoretically. Not always, but it's something to think about, and it constrains the kinds of experiments we can do sometimes. We'd love to have the time and the ability and I guess kind of the organization to do the more theory-driven stuff, and that's fine, but it can definitely lead to kind of glossing over various factors that might be more important down the line because we're focused on one particular outcome as opposed to what might be causing that particular outcome. So lack of iteration. This I think actually Valve as a company does pretty good with. We're actually pretty. It's kind of the way we operate, is making these small incremental changes, measuring feedback, measuring the results of some process, and then incorporating that feedback and moving forward. But it is a problem, right? Is where you have data and you have a finding, and then research stops. In academia, you could pursue the attentional blink for 30 years if you wanted, and keep running small minute variations and acquiring more information about how and why things are the way they are. But it can be tricky sometimes when, again, going back to the notion of what to work on, when our priorities change. And so it'd be great, obviously, as with everything, to have more time to iterate on the findings we have. And we do a pretty good job of that, but we'd love to do more. The other kind of key point I want to make is it's an issue that can exist, right, is not operationalizing what success means. Again, this goes into results-oriented experimentation, but we want to know what a good outcome is. And that's placing a value judgment on what's happening, right? Like we think more players playing the game is a good thing. It likely is, may not be, right? Like maybe the game is better suited for with 1 million, and at 2 million things break down in various ways. Certain things are obviously like measuring, like more people are purchasing, that's fine, we're making more money, hopefully our customers are happier, they're playing the game longer, that's great. But like, how do you measure kind of, for example, like how do you measure success when you're like measuring the toxicity of a game? Like, are people being nicer? Well, I mean, there are ways to do that. You could look at chat logs. We have, and in our games, you can report other players. Maybe reports go down, but there could be other factors that could contribute to that. Like, how do you actually quantify toxicity in a game and then measure success there? Is it just word of mouth? Like, people are like, oh yeah, people in Dota are nicer these days. Is it more new players entering the game? Does that mean that like the perception of Dota is, or any game really, as having a toxic environment is decreasing? It can be trickier, and so having a good operationalized definition of success is important. The last one is actually a problem that we don't currently have, but it can be an issue when you're running kind of smaller sample size playtests. We have, I think 100 million people on Steam, and Dota has 10 million a month, and so we don't lack for statistical power when we do actually run experiments, which is kind of nice. But it can definitely be a problem. Wanting to make sure that, particularly effects with the small effect sizes, can be detected. If we're running it on millions, then we're likely pretty good. But if we're running playtests with 20 people, maybe there's a problem. And so again, it's just an issue that can come up with experimentation. So what information are we missing? This is just my really quick summary of what could be going on. Things that I find interesting, and yeah, you guys will have much better ideas of what we can't currently measure. But player sentiment, getting in better insight into a player's emotional state. We're starting to with facial expressions and EEGs and the SCL stuff I showed you earlier. But it's still a problem. We still don't have a really good kind of moment-by-moment analysis of how a player is feeling while they're playing the game. Understanding rationales for player choice, the factors that go into purchasing decisions. Why are games popular? How much of it is sequel-driven, familiarity with the genre, the company that makes the game, random noise, right? It's likely a lot of it's random, unfortunately, just given the way that preferences seem to be determined arbitrarily. I'd love to know, have a better understanding of what factors actually contribute to that. Measuring game balance. We have certain tools that can do that, but we're not great at it. Operationalizing fun, operationalizing immersion. Those are words that people love to throw around. I'm going to give you my definitions later on, so this is like a tease. I kind of already hit it at fun, how I would measure that. But I mean, having a better understanding of actually how you define fun. How is this game fun or not? Or how would you define this game as immersive? Then obviously the ... is to imply that these are, I guess, 7 questions out of thousands. So this graph I only have up here because the actual content on the graph is silly. It's something I made in Tableau, and this has no actual utility whatsoever. But broadly speaking, each set of colored circles represents a different point in the game, and the items you can buy. And Dota has a bunch of items you can buy for your hero. Has a bunch of items you can buy, and the size of a circle represents the popularity. And so you can see that, this I think is the timestamp for 0. People start by buying what's called a tango, which is an item that heals you. And people at timestamp in 5 minutes they still buy tangos, and at 10 minutes they still buy tangos and whatnot. So again, ignore kind of the shape of the graph. It's a useless graph. But what it shows is information about what people are buying at different points in the game. So what items are they putting on their hero at different points in the game? And that is really interesting. Why are people buying, the items they buy at 15 minutes different from the items they buy at 10 minutes and 5 minutes and at 20 minutes and so forth, and items get more expensive, and the choices they make impact what items they buy, and what's happening in the game impacts what items they buy. So I have this graph up here because there's a lot of useful information in there that I don't know how to get at. I don't have the data that says they made this choice because. And that's what I want. I want that because. I want to know why at 20 minutes people bought item X. And we don't have that. We can infer that, and we can think through that, and we can be smart and rational and analytical about the choices they made. But I don't have a good way of figuring that out. It doesn't exist. I can't actually be okay, these are the factors that led into an item purchase decision at this point in time, and this is what's happening. If we had that, man, would that data be valuable? Not only just for Dota, but for games in general. Understanding what factors went into the decision to purchase an item in game that helped your hero. And obviously there are so many situations and lots of external factors going on. But I want a better model for for the data that led to this graph. And then I want to make a graph that you could actually parse and understand. But that's secondary. I want to understand why these circles are different sizes, and why some groups have, why people buy more items at 20 minutes than they do at 10 minutes, and why they buy less items at 45 minutes than they do at 40 minutes. So yeah, again, ignore the graph, but the point behind it is so much information we have. We're tracking everything, or as best we can, but there are so many questions that we just can't currently answer because we don't have the tools. We don't have either good ways of measuring the data or extracting the data, or maybe even analyzing the data, which is kind of the whole point of this talk, is that just there's so many interesting things we could be doing that we can't yet currently do. And I'd love to be able to understand this graph and parse it and figure out hey, these are the factors that lead to player choice in Dota, at least with item purchases. Continuing on the theme of incomplete information, with everything, right? We always want to get to a behavioral correlate, right? You want some sort of behavior change. Players are sensation seeking. Okay, well, what does that mean behavior-wise? Players seek a challenge. What does that mean behavior-wise? These kinds of people are more likely to make a purchase. Well, give me the behavioral correlate that shows they made more purchases. Players who play this one game are more likely to play this other game. Okay, well, let's see the behavioral relationship between them. Let's see that the purchase rates kind of correlate. So I want behavior. That's what we all want. We want some sort of behavior that corresponds with any notion or assertion or theory that we have, some way of measuring it. And we obviously, it has to be measurable. I mean, I'm saying the same thing, just both times. I just wanted to emphasize, I want more behavioral correlates, and I want to be able to measure them. I want to know, the correlates of emotions and the correlates for player choice and the correlates for explanations of behavior. I don't want stories. I don't want abstractions. I don't want conceptual formalizations. I want a behavior. If players are A, they're going to do B. That's the form of the relationships I want. And we have a lot of if players are A, a lot of theories about what A could be. We don't always have a lot of B, what players are actually doing. And so, coming up with better ways, of measuring behavior. And, we can be smart and tricky about it. Maybe we just use surveys and measure implicit beliefs. That's fine. And then we can correlate that with some indirect action in a game. That's fine. I'm not asking for a direct mapping. I just want to know what the behavioral correlate of players who like challenges. Or this guy is 50% likely to become a whale in a game, whale being people who spend lots and lots of money in a game. Or this person is likely to buy these sorts of games. Or this person is going to be a positive, have a positive impact on the community. How do I measure that? I can think that it's true. I want the behavioral correlate of that. I want to see the result. I want to see the positive impact. So he brings in 10 new friends. Okay, maybe that's one way. Maybe these 10 new friends are assholes. That would be a problem. So I want behavioral correlates for everything. We always want to know, whatever we're trying, it needs to be measurable in some way, quantified down to some change in behavior that players exhibit. If we don't have that, then we don't have good data. This is just kind of emphasizing the point. Again, apologies for the kind of scale of the graph. It's not too important, but x-axis is dates over time. And what this is showing is reasons a duel might end in Team Fortress. A duel is just something you can do. Right? A Team Fortress is a game where you have up to 32 players on a server, 2 teams, 16 versus 16. And in a duel, you can challenge a player on the other team, and whoever kills the person, well, I challenge you, either you kill me or I kill you. Whoever does that first wins the duel. Duels can end in a variety of ways. People can kill each other. Which is the blue line. Just it can end because the round ends, which is the orange line. The server crashes, which is the green line. You can see it down. Or I think maybe it's that guy. But the point being, the reason I have this graph up here is because if you look here, this is just duels ending normally. Somebody killed the other player. It increases here and decreases here. I think this is around December is where it starts. It peaks in March and April and decreases in June. So that's interesting. That change in slope is statistically significant, quite actually substantially so, because these are millions of data points here. Why did this happen? I have no idea. I have zero idea. We have, we could postulate whatever we wanted, seasonal effects, who knows, right? I have no idea why that change happened, why, duels went up, or why, the count of duels went up and then down. I would love to know. But I don't, so my data is incomplete. I'm missing it. So again, it's just an example of a finding we have that could be interesting, could have shed light on what we're doing, and we don't have an answer for it. And I wish that I did. I mean, maybe it's noise. We run a bunch of statistical tests. We're going to get a lot of noise, but I want to know why the trend has been decreasing. Duels are becoming less popular, but whatever, that's fine. But I want to know why that happened. I'd love to know, and I don't. It makes me sad. Okay, so that was kind of I know it was a long overview of the current state of affairs. I'm going to go through these last 2 sections a little bit quicker. I think I'm taking too long, so sorry about that. So let's get to the kind of the path between the present and the future. I have a poem up here because you don't normally see poems in talks, and it's kind of, this is the road not taken by Robert Frost. Most people are familiar with it, I think. But really, it's just kind of emphasizing the point that to make progress, to get to the future, right? Let's travel down the untrodden path, right? Let's take the new path. Let's try and figure out what people have yet to do, and go down there and do that and figure things out. So let's fix the problems we face, gather new data, and try out different things. So for data collection, I'll explain the Sean Bean, I guess, picture in a second. For data collection, you're cleaning up our data sets, right? I mean, this gets down to, throwing out outliers, identifying biases, tracking more data, making sure that we're matching up methodologies with suitable data, right? If I'm tracking attention, I probably shouldn't use a survey. I can ask people where they're attending, but it's much better if I use an eye tracker. So just trying to make sure that, hey, the methodology I'm using is best suited to answer the data I have. And obviously, again, keep identifying the things that are tainting or contaminating our data. And I bring that up because, one does not simply resist Steam deals. So for those of you unfamiliar, on Steam, we have sales that people get quite excited for. We discount quite heavily, and people spend lots of money, and that's great. And so we're like, yeah, sales are great, and the long-term sales curves stay the same, so you don't impact sales. You just get more money, and everyone's happy. But so we could say Steam sales are a good thing, right? But they're not happening in isolation, right? Like at Christmas, people have more money. We have a holiday sale, so people are spending more money anyway. Sales are not happening in a vacuum. Like 10 games could be on sale, 100 games could be on sale, 1,300 games could be on sale. And so those are all impacting people's decisions to spend money on games. We're setting up temporal expectations. Even though the long-term sales curves tend to be the same, people know that in the summer and at Thanksgiving and at the holiday season, the games are going to be on sale. The general notion, yes, sales are a good thing, is fine, but there are confounds in the data, right? There are factors impacting why people are making, deciding to buy a game on sale. And so they don't need to be bad confounds, but they need to be identified and say, okay, hey, let's identify them. And when we say sales are a good thing, and let's give a fuller picture of the factors that are going on. 50% of this was driven by the fact that it was a discount of 50%, and half was at the base price was under $10. I guess 50% and half means I have no room for the wiggle room. We'll say 50% and 40%, and then 10% was the fact that it was Christmas. Who knows? It's just making sure that even something as kind of straightforward as the game was on sale, more people are going to buy it, can be affected by other factors, and we want to be smart about that and account for them. So for data analysis, how do we get better? I mean, obviously adding technical ability, the familiarity with more tools, and so forth. Giving people the ability, people who are not kind of mathematically rigorous, the ability to use more statistical tools, and teaching them, whether it's through the online learning or better development of the tools themselves, like what kinds of tests to run, and how to interpret the data, and making sure that, hey, if I'm running, testing 100 different experimental conditions, that I'm likely to run into spurious effects, right? Just making that effect more salient, right? I mean, in academia we have this problem, right, of people not being able to parse statistics. Well, the problem is worse in industry. Right? Everyone's familiar with problems with the fMRI stuff, right? I mean, people are just, in various ways, can kind of create spurious effects. Well, we have that problem too in industry, and so coming up with, if we're going to be running analyses with our tools, making sure that people are aware of the problems that can exist, that's really important. And then adding in the automation of analysis, this gets back into the data mining side of things. I want somebody smarter than me, so some kind of algorithm, just running on our data all the time and saying, hey, here's an anomaly, here's a discrepancy, here's a pattern that we match that's interesting. One quick example of that, this is a graph of, I think, server usage at, a snapshot in time, I guess, probably in your early evening in Europe, for a particular game. As right now, we have tools in place that will say, hey, there's a deviation in kind of server population from the expected. All of a sudden, if people stop playing on Western European servers for some reason, whether the servers are crashing or some other factor is happening, we have algorithms in play that will say, hey, okay, there's a warning, there's a deviation from baseline, come take a look at this. Well, I want more of that. I want more algorithms running saying, hey, there's a deviation in baseline. People are playing less or more, or buying less or more, or choosing different heroes, or choosing more of the same hero. Who knows? Or playing a different game mode. We can all think of thousands of examples. I want more of that. I want to know when our baseline is being deviated from, and I want somebody smarter than me running tests on thousands of different baselines. Because I can look at one at a time and figure things out, and that's fine. But I want smarter tools. And we have some of that, but there's a lot of work to be done. So we're definitely far from it. For data interpretation, right, it's just being honest about biases. We know they exist. We don't always want them to exist, but we need to be aware of them. We need to be honest about their existence, and then we need better tools to work to remove them. It's going to be tricky. I don't have, if I had solutions for how to do that all the time, I'd put them up there, and I don't. I have notions that I want to remove them. I'd like to remove them. But I don't have, a magic bullet for hey, how do we clean up our data sets in this fashion? But, it starts with being aware of them. So if we're honest about their existence and say, hey, we have this really cool finding, but here are the caveats as to why it might not be exactly what we think it is. Okay, that's much better than saying, hey, we have this really cool finding. I don't want to ever delude myself into thinking something is happening when something else is happening. So for experimentation, I could give an entire, I don't know, day-long treatise on just that first bullet point, the scientific method. I love it. I think we all love it, I guess. I assume we all love it. But being able to better apply it into what we're doing. And the next slide, I think, talks about that, so I'll save it a little bit. But again, if we're not running fully controlled scientific experiments, understanding the limitations of what we're doing, whether it's retrospective or prospective, and whether we're measuring a correlation or it's actually identifying a causal link, and making sure that we do more iteration. And then obviously adding theories and knowledge to the world. It's easier in academia. We have conferences and publications, and it's kind of the goal is to get your work out there. In industry, it's a little bit trickier, right? For various competitive reasons, we may want to keep things quiet, which is good for Val maybe, or good for another company that found something out, but it becomes trickier. And so, we all benefit when theories and knowledge are added to the world, but sometimes, we have constraints in place that preclude that. And so that's a problem, right? That's, it means that, everybody's not getting smarter at the same time. And if everybody's getting smarter, then more people are thinking about tough problems, and everyone, gets multiplicative, and then we all get smarter. It is an issue, right? It doesn't need to be like a bad thing in isolation, because there's a reason that companies keep things to themselves. But the more that folks share, well, in the long run, the better off all of us are going to be. So this is, the scientific method. Everyone knows it. I have it up here just because I'm going to harp on it, and I wish we could do more of it. You can start anywhere in the chain, but I want to take an observation, generate a theory, make a prediction based off that theory, and then run an experiment and analyze and gather the data I get from that experiment. Right? That's what everybody does. That's what you guys in academia get to do all the time. I get to do this some of the time. When I was in academia, I got to do it a lot more of the time. And again, we talked over some of the constraints about making changes to games is really tricky, at least especially after release. But this is the single best method we have for creating knowledge and adding knowledge to the world. It's worked for thousands of years. It's going to work for thousands more. It's fantastic. And so, whenever I guess I'm kind of gathering data or running an experiment, I'm always trying to wonder how far away I'm deviating from this process. It keeps me grounded, it gives me a goal. This is my goal for everything we do, is to have it mapped to this as, as cleanly as I can. And when it does, I'm really happy, and when it doesn't, I get sadder, but then I get happy again when I can make it work. So I'm not always sad, so you don't have to worry about me. But the point being is that this is the gold standard for how you add knowledge to the world, and there's no reason why what works in science and academia and basic research wouldn't work just as well in industry. So as best we can, this is what we try and adhere to. So new kinds of data we could be looking at, data that'd be really interesting, obviously stuff that we could do in real time, and I'll unpack that in a second. Definitely getting more complete, data, and I'll unpack that as well. And then being able to do more experimentation and dividing people up into experimental groups would be fantastic. And again, apologies, I think I'm really over time, sorry, so I'm going to run through this pretty quickly. So I suck at, organizing my thoughts. My apologies. Okay, so I'll start going really quick. So for real-time analysis, I'd love contextual surveys. Like right after somebody does something in a game, I'd love to know why they did what they did. After they made a purchase, after they chose a hero, after they won a game, lost a game, I'd love to know what's going on. I'd love to be able to do manipulations in-game. When someone does action A in-game, okay, we could give you sets B, C, and D and see what happens. That can be tricky because you don't want to negatively impact the game experience for players, but I'd love to be able to do that. I'd love to know player sentiment, right? I want to know in real time what a player is feeling. Are they feeling happy, aroused, sad, challenged, disgruntled, whatever. I'd love to know that. This is just one example of, somebody, we're measuring skin conductance. This is just their arousal level over time. These are events that happened in Left 4 Dead. Tank is a boss, a smoker's a special infected. You can see spikes in arousal at various points. I'd love to know if those spikes are positive or negative. Like, are those happy spikes? Are those challenging spikes? Are those frustrated spikes? We can get at that with facial expression, maybe. I want to be able to do that in real time for everybody. That's what I want. We don't have it yet, but that's what I want. For complete data sets, yeah, I mean, some of that is just kind of hardware driven. We need, more efficient, hard drives, more efficient processors, and we need, an analytical tools that let us make smarter inferences. We also could do some spatial analysis stuff. We have a whole bunch of movement data, like people moving around in games, and like maybe that we could, infer estimations of skill. Right? Or estimations of frustration, or hey, we did this in Portal, like Portal is a puzzle game, it's a first-person puzzle game, and by looking at eye movement scan patterns, we could tell if, hey, they were in like, goal-directed, like, they were either in problem-solving mode or they were in what the fuck am I doing mode. They didn't actually know. And you could infer that from the eye movement patterns. You could look at it and say, hey, oh yeah, like, these sporadic jumps around, okay, they don't know what they're doing. Oh, hey, they're looking at particular landmarks, they're in problem-solving mode trying to figure it out. And you could actually measure the aha moment, which is kind of cool. So, I mean, you could look at spatial analysis of attention, spatial analysis of player movement patterns, the heat map I went to before, spatial analysis of deaths. I know there's a lot more that could be done. That's one example. There are tons more. Yeah, going back to experimentation, right, I want to be able to segment players. So we have sample sizes in the millions. I want valid controls. I want valid experimental conditions. Red pill and the blue pill. I want to be able to run that experiment on 1 million Dota players on Monday, and the blue pill, 1 million Dota players on Monday, and the red pill, 1 million Dota players on Tuesday, or the following Monday, if I wanted to account for day of the week effects, perhaps. But I want the ability to do this in-game, divide my players up into groups, and say, hey, we're going to put half of you here, half of you there, and see what we find. More novel methodologies that could be added. I mean, people are starting to use biofeedback, getting measurements of arousal, measurements of valence. Eye tracking is becoming more popular. You could get stuff from posture and from gestures. We could measure smell. Depending on your emotional state, things will smell differently to you. We could try that out. Maybe there's something there that would work. EEGs, the consumer grade stuff is not there yet. It's nothing compared to what you can get in the laboratory. But getting more information about a player's physiological state would be incredibly powerful. To know, at various points in time, how challenged was the player feeling? I'd love to know that, and we currently don't. This graph is, again, just kind of saying, what could we do with physiological data? This is a map of estimated kind of like arousal level in a game. This is a desired population of zombies that could appear in the game, and this is how the actual population was generated based off this arousal level, and you can see there's peaks and valleys in what we believe the arousal level would be. We actually did an experiment where we took this estimated arousal level, which is based off of like your health and how many zombies you've killed and how long you've been playing the level, and replaced it with your actual galvanic skin response, and then have people rate like the quality of the game afterwards. And if you take the estimated arousal level, replace it with the actual like physiological arousal, and ask for subjective responses afterwards, people are happier with the actual arousal level. Like their actual, like if you say, hey, like instead of estimating what's going on, you measure their physiological data and say, hey, using your skin conductance, can we determine your actual arousal level and create the game, create the desired population based off that arousal level, do you have a better experience? And you did. I want to do that all the time. I want to find out the optimal pattern of arousal in a game. Is it steadily increasing peaks and valleys? Is it one giant peak with a giant valley? Who knows? I want to know that, and I want to use that and make better games because of it. So novel methodologies on the analytical side. We could definitely do a better job with Q&As. We could, measure things more implicitly with surveys, right? Again, I talked about the explicit, implicit, difference that people tend to have. I want to remove bias in verbal reports. People suck at telling you why they do what they do, right? Choice blindness. People will create rationalizations for, choices they did not make. They want to impress you. They don't always know why they did what they did. They pick plausible signing interpretations. I want to remove that bias from verbal reports. I don't know how to make people more honest, but I'm going to try. This is my my measurement of fun. Letting people play for as long as they want. I have, it's in red, maybe the single biggest change we could implement. If we just, in playtests, let people play for as long as they want, and said, hey, yeah, this week people played for 45 minutes, we made a change, and they played for 47 minutes, and that was meaningful, that's how I'd measure fun. Definitely pick at that, and I'm sure there's cases where that's not always true. I wish we did more of that. We can kind of do that now when we measure, after a game has been released, we can measure how long people are playing for, and that's one metric we use quite a bit. But I wish early on in playtests we did that. Instead of having structured playtests where they play for an hour, hour and a half, or whatever, we say, hey, come in, play for as long as you want. And that's how we're going to measure fun. I love better ways to test multiplayer games. The population space or the potential space of problems goes to infinity almost. We have some ways of testing what can happen in multiplayer games, measuring game balance and emergent behavior and interactions, but we're still far from it. And so I want to know how we test multiplayer. I want to know what I haven't thought of course. Again, this is just my lazy, hey, let's ask more questions and figure things out. Okay, so finally to the future. This is the last part of the talk. It's not too long. Again, sorry, I'm kind of messing up the schedule here. But with the future, it's like, okay, so what's our perfect world? Are any problems unsolvable? Is any data ungatherable? I have advertising up here because if you know a way of measuring the effectiveness of advertising, I would love to hear about it. Because I know lots of people think it's effective. Very few people have meaningful ways of measuring it. Are TV ads effective? You know how I'd figure that out? I would run a TV ad in half the countries, or half the cities in the country, equate them with the other half of the cities in the country, and then measure the change in purchasing behavior. Do you know who's done that? I don't know either. Like, I don't know, I've never read that study being done once. Now, that's how I would figure out if TV advertising is effective. You get, two equated populations with cities that have, similar socioeconomic status and so forth, and then you say, hey, half of you get TV ads, half of you don't. How much did sales increase or decrease? I mean, we all anecdotally believe that, we're increasing brand awareness, things are happening, but, the effectiveness of advertising is still an unsolved problem. It's an almost $1 trillion industry that doesn't have rigorous science underlying its impact. So I'd love to know. If anyone has a link to that study or knows that someone has done that, I'd love to hear about it. So I have advertising up there because that data has not been gathered yet, which is kind of surprising. So in our perfect world, our data is clean, it's complete, it's free from bias, it's adaptable, and we can measure anything, and we can temper that and say it's cleaner, it's more complete, it's free from bias, and more adaptable, and it can measure most things. But I want, again, going back to the behavioral correlates, I want some way of measuring any kind of assertion I make. And so again, I'd use this more as not because I'm like, I understand this is idealized and kind of a almost meaningless slide, but the point being is that thinking about ways that we can make our data fall under these categories, make it cleaner, make it more complete, and so forth, helps me become a better researcher. Because I start thinking about how do I solve methodological problems, and how do I get into how can I draw more meaningful conclusions from what I currently have. This is just a dumb slide of me from 6 years ago. The reason I have it here is because this playtester satisfaction index, our fake little pie chart there. I'd love to have a good metric of that, of how happy our players are when they're playing the game. I mean, we could correlate that with fun somehow and go back to my notion of how long are they playing the game. But I want this. I want some sort of behavioral analog for playtester satisfaction. We don't currently have it, but in our perfect world we would. So for data collection, we collect everything. It'd be really easy to add hooks to gather data. It'd be instantaneously available for analysis. We'd have better tools for identifying confounds. And again, going back to the verbal reports, people would give more honest responses. This may be the hardest problem to solve here. I'd love to think about ways in which we could not prime people. And if you've never asked a leading question in a Q&A session, then you're a far better researcher than I am, because I try my hardest, but I will often find myself phrasing things in ways I'm like, nope, that was not good. I have to strike that data because I asked that way. I asked that question in a way that kind of presupposed a response, and people gave me biased data. But I think about this often: is how to get more unvarnished data from the people that we're examining and experimenting on. So for data analysis, again, we've kind of gone over this, but I did want to make these points. I mean, letting people know which analyses are most useful in various situations and helping them walk through the pros and cons and what assumptions are being made would be very helpful. Making the tools available to easily explore data sets and doing a better job with the machine learning stuff, making sure that we have these automated processes that are constantly going. So in our perfect world of data interpretation, I want to account for biases, I want to remove them, I want to prevent them. You can't get to the latter two steps without accounting for them first. You need to identify them. Once you have them, maybe you can remove them, maybe you can prevent them, and then off you go, and you get cleaner data. Constraint removal, these are the 6 guys I had up there before. What it comes down to is giving us more time. Time solves almost all of this. And so as we think more and more about ways in which we can improve our processes to run more people or gather more data or analyze more data efficiently or not need to run as many people to actually draw meaningful conclusions from our data, then we get better. And so trying to think about how we can allocate resources and do a better job of kind of letting us, giving us more time to solve, if we had more time, that we can get the equivalent of more money, more equipment, more expertise, more storage space, and we can solve more issues. And so I'd love to figure out how to make our processes more efficient, and that's something I'm constantly thinking about. So I think we can answer, this is the list of questions before that I posed that I'd love to have data on. And in the perfect world, I think we can get information on all of these. Again, I'll just come talk to me afterwards if you want to hear my specifics, but we can measure sentiment, or more of my specifics. We can measure sentiment through physiological stuff. We can get contextualized surveys and get choice. We can do the same thing for purchase decisions, perhaps. Game popularity is trickier, but I bet if we're smarter with our kind of algorithms for what data we put into neural networks or whatever, we can measure that. Game balance is something we can talk about afterwards. But trying to operationalize that in some fashion, I think is a thorny problem. And we could start by if you take a map, and if each team on the map wins 50% of the time, okay, the map is balanced in theory, but that's the starting point. I think we could do a better job of that. Fun, I gave you, measure how long people are playing the game. For immersion, my best guess at how I measure that is imperviousness to distraction, and imperviousness to certain kinds of distraction. I know people have been working on that, and people have kind of theoretical frameworks that apply to that. But I'd love to have just kind of a pretty useful framework where it's hey, this game is immersive because people are immune to 92% of visual distractions that could appear on screen, or 87% of onsets and 37% of color changes, and have some sort of metric that says, hey, this is how immersed they are in the game. Questions we can't answer. This is my cop-out slide. I don't actually know. This is my, let's be optimistic and figure things out. I don't know what we can't answer. I'm sure there's a ton of stuff we won't be able to get to, but I'm not going to rule anything out now, and I'm going to say, hey, okay, there's a ton of data out there, lots of interesting questions. Most of it we can answer, and whatever we can't, well, we'll think that until someone smarter than me comes up with a way of figuring it out, and then we can answer it. So this is more of just saying, hey, okay, I'm not going to rule anything out yet, because I don't have, there's nothing up there, nothing I've talked about where I'm definitively we can't answer that. I just think we haven't yet. So that's me being overly optimistic. I'm sorry. So the problems that are made, and obviously this is a theoretical exercise, we always have constraints. Our tools will never be perfect, our data will always be biased, and that sucks, but the point of the talk was not to say, hey, this is what's going to happen. It's more this is what could be happened, this is how we, where we could get to, and thinking about ways in which we could get to a more perfect or idealized world is always a useful kind of framework for things. So what data remains? I keep banging on behavioral correlates. I want a measurable behavior. When people do A, when people are like A, they do B. I want that B. I always want that. What's going to be hard to get? Access to introspective processes. People are, again, really bad at telling you why they do what they do. They're forgetful. If you don't poke at them at the point in time that they're making a decision or they have an introspection, you're going to lose it, or it's going to be contaminated. Coming up with a good way of getting access to that is going to be tricky. I don't have a solution for that. I mean, we can do the contextual surveys. You can do real-time analysis of emotional state, but a lot of that data is going to be missing. So it's going to be tricky to get. And then there's measurement of situational factors. If there's a holiday in China, that's going to impact our data. That we can measure. If a new game came out and lots of people are playing it and we don't have data on that new game and that impacted data we saw, like our player counts went down, that is tougher to measure. And so accounting for that and understanding, hey, what are the factors that actually led to this? We're always going to be missing certain things. Our picture of the world is not complete. And so that's a problem that exists and something that we'd like to solve, but it's likely something that will kind of always be, I guess, sometimes will be out of our reach. So yeah, this is exactly how every chat in an online multiplayer game goes. Of course, everyone's familiar with that. It's actually not, surprisingly not. I have this up here because I'd love to make this happen, this be the norm. How do I get there? We're working on it now. We're very far from it, but I want this to be the norm. And I have ideas about how to get there, but we're not there yet. But in my perfect world, we've solved this problem. This is how people behave. People are always happy and willing to help, and they understand that not everyone else is perfect. So yeah, getting to there would happen. This is my perfect world, is having this happen. Almost there. So the quickest path. we're right at the end. Just being aware of biases, acquiring more technical ability, doing information exchanges. Like, I will always talk to anybody. I guess if there's certain things I can't always share, at least if it's like confidential, like proprietary or whatever, but I'm much more inclined to just talk to people. And so this is why I come to conferences, this is why you guys come to conferences. The more we share, the smarter we all get, and the better the games and then research we're going to create. So I have this last point in green just because it's my favorite thought, is never stop questioning. Every assumption I have, I'm always poking at myself and asking the second question. Right? I think this. Why do you think that? This is my assumption. Why do you think that? This is my starting point. Why is that your starting point? This is what my data shows. Why does it show that? Never stop questioning. This is the whole point of this talk, is just, okay, if I think about what the problems that exist and where I want to go, and ask questions about how I get there and how do I solve those problems, well, then I become a better researcher. I make better games. So I'm never going to stop questioning. More easy wins, again, letting people play as long as they want. I have be aware of biases up there again a second time on purpose, because it's really important that I'm cognizant of the ways my data could be affected or impacted or shaped, and I want to do the best job I can to account for them and remove them. I think doing biofeedback, measuring physiological signals is fantastic. Obviously recording more data, and if I could run experiments all the time, I would. And so I'm hopeful we get to a point in the future where I can run experiments on our player base to define causal linkages and add knowledge to the world and make better games because of it. So I'll leave you with this. This is one of my favorite quotes ever. It's by Sagan. If it can be destroyed by the truth, it deserves to be destroyed by the truth. Right? We don't want to believe what we want to believe. We want to believe what is actually the case. We want to leave our preconceived notions and our expectations and our assumptions and our assertions at the door and say, hey, what is actually going on? What is the state of the world, and how do we get there? So if it can be destroyed by the truth, it deserves to be destroyed by the truth. Thank you very much.